So today I'll be talking about a typical example of an optimization problem, and these are pretty much a huge common culprit in past Maths Advanced papers. And pretty much you're literally just expected to know how to replicate this entire process. So this particular example, which is fairly minimalistic, I'm given a rectangle with length L and breadth B. I will impose a restriction that the perimeter of the rectangle must be 1,800, and then I'm asking you to find the maximum possible area of the rectangle. So to do that, what I'll firstly do is address my restriction, which is step 1, as you can see over here. And, well, I know what the perimeter of a rectangle is. That'll just be 2L plus 2B. And it turns out by rearranging this expression, I get a nice expression for B in terms of L. And what I can then do with that is now sub that into the formula for the area, because that is what I'm trying to optimize, or in this case, maximize. And then I'll get an expression for the area in terms of only the length, and well, that's nice because now pretty much I can differentiate this thing. So I'll obtain dA dL is equal to 900 minus 2L, and for all of the values of L that I am interested in, I only care about when the first derivative is equal to 0. In my case, that will be when L is equal to 450. And then don't get into the trap of saying, oh, therefore that's it. Remember, when dealing with these problems, we need to always look to the second derivative as well, in which my case, that will be fairly easy. That'll just be minus 2. And I just want to check that when L is equal to 450, the second derivative is negative. Well, here it's kind of obvious because minus 2 is less than 0 regardless of what L is, but pretty much just by having done this little check, I've made sure that the value L is equal to 450 is the value of L that will actually give me the maximal possible area. So the maximal possible area will therefore just be A is equal to 900 times 450 minus 450 squared, units squared. And pretty much whatever answer I get from plugging that in the calculator will be my maximum possible area. Thanks for watching.